Hello, hi everybody. Myself Alavat Ramesh. Especially today we will talk about electrochemistry, basics and fundamental of electrochemistry. And especially in chemistry, electrochemistry is one of the branch, and it is used in many purpose. How the electrochemistry applicable in different purpose you can see in this YouTube. Now we can see the electrochemistry basics and fundamental of electrochemistry, and you can see that first the term of electrochemistry, anything that has happen from pin drop to explosion required energy. So energy is the capacity for doing work. Various forms of energy exist, including light energy, heat energy, sound energy, electrical energy, chemical energy, nuclear energy, potential energy, kinetic energy. So inverse is fixed energy cannot be created or destroyed, but we can convert one form to another one form energy. That is the one basics fundamental of universal truth about the energy. So electrochemistry is the study of electrons movement in an oxidation and reduction reaction at a polarized electrode surface. Electrochemistry and electricity can be generated by movement of electrons from one element to another in the reaction as known as redox reaction. So generally, what is redox reaction? The oxidation and reduction simultaneously happen in that reaction is simply will call as redox reaction. So electrochemistry is a fundamental for our transition from fossil fuels to carbon neutral life. So batteries, solar cells, fuel cells, and conversion of into the product. So sustainability, energy conversion, and energy conservation and storage, new battery systems, fuels are some example of the electrical energy. Alan L. Bord 1933 to 2024 is known as the father of modern electrochemistry. He is the one of the father of modern electrochemistry. Now coming to the generating electricity from magnetism. For example, electric generator. Generating magnetism from electricity, example, circuit with electromagnet. This relation is called inextricably. So what is electric circuit? So if the charge are free in, suppose you can see here, the charge is while the materials that allows the electricity or electrodes to pass through the force caused as flow of charge called as electric circuit. So we will repeat once again, if the charges are free in the wire or any material that allows the electrons to pass through the force caused as flow of charge called as electric current. So what is magnetism? Some substance exhibit the storage phenomena is called magnetism. And electrostatic, the charge is a fundamental property associated with matter due to which it produce and experience electrical and magnetic effect. Energy plays a vital role in the development of activities of nation. Energy resource are two types: conventional resource, non-conventional resource. Resource, main energy resource are two types. One is the conventional resource, non-conventional resource. Conventional resource means non-renewable resource and exhaustible, and they can be exhaust one day or moreover they damage the environmental system. Example, fossil fuels, nuclear power and hydropower. And non-conventional resource means inexhaustible energy or renewable energy. Example of solar energy, wind energy and water energy. So energy sources are mainly two types. One is the renewable energy, non-renewable source energy, or simply conventional resource and non-conventional resource, or exhaustible energy, inexhaustible energies. Then coming to the electricity and magnetism. Electrical effect result from an imbalance of electric charge. There are two types of electric charge named positive carried of protons and negative carried of electrons. If the charge are opposite, unlike they attract one another while light charges repulse. The force of attraction and repulsion, the force of attraction and repulsion is known as the electrostatic force exists between any two charges particles. The electrical and magnetism relationship, the electrical and magnetism, the relationship is between that inextricably. Okay. Now we coming to that battery chemistry and corrosions. Storage batteries. Any device that stores the chemical energy and release it has electrical energy is called as battery or storage battery. Cell is a device in which chemical energy is converted into electrical energy. Many cells connected in series are called as battery. Batteries are classified into mainly three types. One is the primary battery, secondary battery, and reverse batteries. Reservoir battery. So what is primary battery? So not all batteries are equal. Often they have the classified under the following batteries. Primary batteries or chemical energy stores in a battery is converted electrical energy spontaneously as long as activity materials are present. Now we can see, in other words, the batteries in which irreversible chemical reaction takes place are called as primary batteries. These batteries cannot be recharged because cell reaction is irreversible. So dry cell, Lang cell, lithium, magnesium oxide batteries. Then second one is the secondary battery. Secondary cells are the batteries in which reversible chemical reaction takes place. This battery can be recharged by passing electric current. A redox reaction is reversed during recharging. So electrical energy is stored in the form of chemical energy in these batteries are used as when needed. Lead acid battery, nickel MH batteries, lithium ion batteries or the secondary batteries. Primary cells act only as galvanic cells, whereas the secondary cells act as both galvanic and electrolytic cell. That is the difference between important. So during discharging, it acts as a galvanic cell converting chemical energy to electrical energy, and during charging process it acts as electrolytic cell converting electrical energy to chemical energy. Now coming to that reserve batteries. In these batteries, one of the key component is storage separately, and it is incorporated into battery when required. When long storage is required, reserve batteries are often used since the active components of the cell is separated till needed, thus reducing self-discharge. Reserve batteries effectively eliminate the possibility of self-discharge and minimize chemical deterioration. Most reserve batteries are used only once and then discarded. The reserve batteries can be classified by the type of activating medium or mechanism that is involved in the activation. So the water activated batteries active by the fresh or seawater. Example, magnesium and silver chloride batteries. They are activated by adding seawater. These batteries have high reliability and long shelf life. Hence they find application in missile and submarine. Then you can see here gas activated batteries. Activation by introducing a gas into the cell. The gas can be either the active cathode material or the part of the electrode. Example, zinc air batteries, where the cell is sealed till use, the seal is removed to admit air and activate the cell when needed. Electrolyte activated batteries. The activation of the complete electrolyte or it the electrolyte solvent. The electrolyte solute is contained in or formed in the cell. Heat activated batteries. So a solid salt electrolyte is heated to the molten condition and becomes ionically conductive, thus activating the cell. Those are known as thermal batteries. Now coming to the electrodes. Electrodes are potentiostats require the electrochemical cell that three types of electrodes. Working electrodes. The working electrodes are where the potentiometry control and where the current is measured. In many physical electrochemistry experiment, working electrode is an inert materials such as gold, platinum, glass, carbon. These are working electrodes are where has the surface which is the electrical reaction takes place. Now coming to the next electrode, you can see that reference electrode. Reference electrodes is used as to measure the working electrode's potential. So the reference electrode should have the constant electrical potential along with no current flow through it. That point is very important. In the reference electrode, there is no point of the electricity flow. The most common lab reference electrodes are the saturated calamine electrode, SCE, they are using nowadays, and the silver or silver chloride electrodes working as a reference electrode. In the field of pseudo reference, like piece of working electrode materials are often used. Then third one electrode is the counter electrode, or simply we'll call auxiliary electrodes. So the counter or the auxiliary electrodes are conductors to that complete the cell circuit. The counter electrodes in the lab, the cell is generally an inert conductors like platinum, graphite using as a counter electrodes. People are using platinum counter electrodes. They are using. If the field, if they are another piece of the working electrodes materials, the current that flow into the solution via working electrode, that leaves the solution via the counter electrode. So the electrodes are immersed in an electrolyte, an electrically conductive solution. This collection of the electrode solution, the container holding the solution are referred to as electrochemical cell. Now coming to that interfacial electrochemical techniques, people how these using nowadays, like you can see that electroanalytical methods also. So electroanalytical methods are the class of techniques in analytical chemistry which study the analyte by the measuring the potential, nothing but of volts or the current amperes in the electrochemical cell contain the analytes. So there are three main categories: potentiometry, the difference electrode potential is measured, and calorimetry, and another one is cell current measure over time, and voltammetry, the cell current is measured while actively altering the cell's potential. So bulk method to conductometry. Then in coming to that analytical, interfacial analytical electroanalytical techniques, nowadays people are using static techniques, dynamic techniques. Mainly the electrochemical techniques are two types: static techniques and the second one is the dynamic techniques. So the static techniques, you can see here, simply we'll call it potentiometry, measuring of the current. In dynamic techniques, again two types: controller potential and controller current. It's a controller current is a calorimetry, the measuring of voltage versus it over time. Then variable potential and fixed potential. Fixed potential amperometry and control potentiometry. And the variable again stirred solution and quiescent solutions. Then hydrodynamic voltammetry, again linear potential, pulsed potential and cyclic potential. So polarograph is the linear potential stationary electrodes voltammetry measures, and pulse polarized and the voltammetry and cyclic voltammetry to measure the electricity. These are the techniques. Now electrochemical techniques people are using. And you can see next YouTube channel